and the blanket are produced captively. They're not wild grown, like most of our other psychoactive drugs.
Wait,
okay.
Someone said that they growing in like Lompoc.
Yeah, so they do grow in Lompoc. I know for a fact. I have seen them there. And apparently someone found some at the Lake Kachuma Reservoir, but those are probably from the recreational users feeding the area. Okay, now, what? Okay, so, if there are no questions about these things, then I need to get back to study goal number 22 in assignment 8.2. And today I'm throwing out a ton of facts. We're getting close to the exam, so I'm motivating, and I'm just going to go straight through the most noteworthy stuff. On number 22, 23 actually, 23. All right. So there's this place called China.
Oh, God.
And I thought that whole thing was just called this is the mighty Yangtze River. The Yangtze River is right along some of the biggest cities in China. You may have heard of Shanghai. I don't even know how to pronounce Nanjing or Hangzhou, but I do know from what other people tell me, and please forget my pronunciation, that the Yangtze River has some of China's biggest cities. And actually, it's not too far from Beijing, which is one of the world's biggest cities. The Yangtze River is a seasonal flood river. It's prone to pretty extreme flooding. Remember we talked about that natural rhythmic nature of rivers. The Yangtze is a very tempestuous river. Historically, people called it an angry river or a heartless river because it has killed a lot of people who used to live along its riverbanks, and it would flood like crazy. Flooding is one thing, but China has also, in its recent growth, encountered limits to energy and water availability. And so the Three Gorges Dam satisfies three separate strategic needs for China: flood control, electricity production, and water storage, making it a perfect example of all the reasons that people have a dam. Water, electricity, flood. Water, electricity, flood. Flood control. The Three Gorges Dam is a record-breaking construction project. I'll give you all the records it's broken. It is the largest reservoir held in place by the largest dam. That dam is the most expensive thing ever built, $22.5 billion. The most concrete ever used. The most electricity generated in one site, the equivalent of 18 large coal-burning power plants. It is the most concrete, the most workers, the most money, the most excavation, the most earth moving. It takes over 4 hours to drive around the reservoir. It's nearly 300 miles around the entire edge of the reservoir. And many people, more and more people are increasingly worried by the disaster that is threatened with this reservoir. For one thing, in its construction, it was a really politically ugly process. About 1.5 million Chinese people lost their homes. Let me get the exact number. 1,200 villages and 2 major towns had to be abandoned and rebuilt at a higher elevation. For a while, the World Bank was going to invest in this to help it be built. Then they backed off because they said it was too much of a disaster. So China went solo, and the price keeps going up. So every time they think they're going to finish it, somebody goes, hey, wait, we need more money. And then they have trouble getting all the money. When the World Bank was investing, the projected price was $8 billion. And the World Bank was going to pay for most of it. As soon as the World Bank said no, China said, okay, we can do it, but by the way, 10 billion, then 12, then 15, then 18, then 20. Now it's 22.5, and it's still not over. Internally, there's a lot of gossip about embezzling and favoritism and money laundering and secret kickbacks and public kickbacks. The economics of the dam have been really dicey. Habitat fragmentation, endangered species impacted, archaeological records. Farms have been flooded, so food supply is suffering locally. Really important archaeological sites. And here's one last detail. Does anyone remember this demo? Remember that, like this paper moving on this table, tectonic plates move on top of red. Those plates are always moving. But water's really heavy, and a reservoir holds a lot of water. And in the geologic time scale, filling a reservoir is, relatively speaking, immediate. It takes 3 to 5 years. You know, a glacier holds a lot of water, but a glacier takes 10, 15, 20,000 years to build. A reservoir holds a lot of water, but it takes 3 to 5 years. So it's like it's taking a huge old paperweight, and right where a tectonic plate is moving, you just pin it in place. But of course, it's still being pushed from somewhere, so that energy's got to go somewhere. And a lot of people are concerned that the Three Gorges Dam will generate its own seismic activity, which would really suck for some people. Because if that reservoir can survive the earthquake, that's going to be a really catastrophic, tragic event. I don't know how much you guys follow politics, but you know the Chinese government has this reputation for being really stubborn. And I don't know if that's true or not, and I don't know if that's fair or not, but this project is probably one of the dumbest projects ever. With all the things we know about dams, and with this being the biggest one ever, it don't make no sense. It's a really silty river, like the Colorado. It's going to fill up with sediment soon. Unlike the Colorado, there are huge cities right on the river just downstream. You know, Las Vegas is near Hoover Dam, but the Colorado River does not run through Vegas. The Yangtze runs through 3 of the 10 biggest cities in China. Great. So a lot of people are really stressed. This is sort of a looming disaster many of us think getting ready to happen any minute now. Anybody want to talk more about the Three Gorges Dam?
Do you have a picture of it, like, recently?
So, no, I don't, but they're on Wikipedia. All I got was these because I got construction photos before it was finished. Since it's been finished, I haven't looked to update this part of the PowerPoint. I just checked Wikipedia this morning so I could lecture about this, and they have photos like on the Three Gorges Dam page.
Oh, it is completed.
The dam is completed, it's 3/4 full. The reservoir is 3/4 full. As it fills, they're having this problem that it's got more and more garbage than they anticipated, because when you flood old cities, you're going to get, garbage. And so they've had so much unanticipated waste in the reservoir that one of the biggest additional expenses is this floating conveyor belt that's supposed to lap up debris. So on the reservoir side of the dam, they call it the tongue. It's this big conveyor belt that has like flaps that lift out of the water and put stuff on top of the conveyor belt. So they've got like these things that take stuff off the surface and flop it onto this thing that feeds it into this giant grinder that I think is going to a landfill that they dug just to the side of the reservoir.
It's going to kill so many swimmers.
And probably no swimmers. Okay. 25 I'm skipping. Oh wait, no, I'm sorry. 24 I'm not skipping. 24 is a big whoop. Check this out. That is the LA River. Only, I think we all agree, that ain't no river.
Well, we call it a river, but it's still better.
Yeah, we do call it a river because it used to be a river. Poor ducks don't know the difference. This, children, is called channelization, to make a river into a canal. What's the point of it? The point of channelization is primarily flood control. You got to know all these things. Secondarily, erosion control. And third of all, in some cases, improved navigation. Like in Europe, they built a lot of canals to connect cities that were otherwise unsafe to travel on land. Throughout the world, channelization is often about transportation. But in the U.S., it's primarily to get rid of the water, limit erosion, while preventing flooding. You turn a river into a gutter. Please look up. You've got this handy diagram in your book relevant to this study goal. I strongly recommend you check figure 21.16. Figure 21.16. Because in that diagram, they've got a pretty good comparison between real rivers and canals. I have extra stuff, so I'll read to you all of that plus my own notes. Yeah, riffle is when surface turbulence bounces off the bottom and technically lifts the water on the surface. So you get rippling. Okay. On the left, you have your natural river. And on the right of the screen, you have canals. I'll tell you what it says in the diagram, but the one key factor